Hi, this is Bob Simon. Welcome to the Data Acquisition Series. In this series, we'll be focused on acquiring data from public Python data sources and pushing that data into our PostgreSQL database. The steps are pretty simple. The first thing we have to do is we have to install those public data source libraries. Then we have to import the relevant Python packages. Then we have to connect to those data sources that we're going to be acquiring data from. Then the data has to be pushed into a data frame, which is a Python term for a table, basically just like an Excel table organized by rows and columns. Then from there, we can take the data frames and actually push those directly to our SQL database very easily. So let's get started. The first data source that we'll be acquiring is NFL play-by-play data. This is an amazing data source because it has a ton of information about every single play that happens in the NFL in both the regular season and the postseason. The reason we chose NFL data as a basis for this training program is because we want you to be actively engaged and incentivized to work on the concepts you learn in these videos between training sessions. Most other training programs will have you focused on very boring data sets that you cannot relate to and will make you want to do nothing but go to sleep. One thing about this program that we should know is that every single piece of code we write will be made available in a GitHub repository, and links to relevant files will also be made available on each video's description. Before we really get started, let's head over to the project page so you can get a little bit more information about this NFL data source. So here's the project page, and a link to this page will also be made available in the video description. You can see the data sources that feed into this Python library: NFL Fast R, NFL Data, Dynasty Process, and Draft Scout. There's a lot of information about play-by-play data, roster information, formation information. Pretty much anything you see on an NFL football field is going to be made accessible to you with this Python library. There's instructions in terms of how to install the library and how to access it, and it starts in 1999, so we have about 24 years worth of data as of the recording of this video. Let's get started with migrating our data to PostgreSQL from Python. The first thing we're going to do is we're going to open Anaconda Navigator, and this is where we will launch Jupyter Notebook. So open this up, scroll about a quarter of the way down the page, and you'll see Jupyter Notebook, not to be confused with Jupyter Lab. Launch Jupyter Notebook here, and it will open up in a new web browser. Okay. We're ready to go. So basically we've got the Jupyter interface, which is very simple. Just looks like a folder structure, right? So all we're going to do now is we're going to launch a new code editor. We're going to click New, which is right above this pane of folders, and we're going to launch New Python 3, which will bring up a blank code editor. Here we're going to rename our file. So I'm just going to call it NFL Data Py to PostgreSQL and rename. Okay, so this is where we're going to input our Python code and we're going to run our Python code. So we have the concept of cells. The idea behind a cell is that we're going to create smaller blocks of code kind of grouped together to perform one function or minimal functions. Then as we build out our program, we'll just add new cells with new blocks of code. What's nice about this, it makes it a little bit easier to follow, a little bit easier to write code, and ultimately you can run the entire notebook all in one shot, or you can run individual cells separately. So if you think back to the intro, we said there's a few steps that we have to take to acquire data and to push it into our Postgres database. The first thing we have to do is we have to install the library. So in Python, the way that we install things is we use something called pip install, which looks like this. So pip install, then the package that we want to install. In this case, it's the NFL Data Py library. And we run it here with the run button. I've already installed it, but it will still run, and it'll just tell me that the requirement has already been satisfied. You'll get a different message, but ultimately the same outcome, which is to have the NFL Data Py library installed. The next thing we need to do is install our Postgres database connector. And we just do the same thing, another pip install. And this time, it's going to look a little bit differently. This is the Postgres specific installer, connector. Other platforms will have a different installation. Snowflake will have a different installation. SQL Server will have something different. This one is specific to Postgres. Again, click run. We'll give that a second. Okay, that is also complete. Now we need to import the libraries and the packages that we're going to use to execute our code. So that is going to be a little bit different. In this case, we're going to import SQL Alchemy. This is our SQL engine, which will allow us to take a Python data set and push it to our SQL database. So we have to have SQL Alchemy to execute, to establish the connection and to execute these SQL statements. Next, we have to import the NFL Data Py library that we just installed. We give it a little alias name here, so when we reference this package, we just use NFL instead of typing out NFL Data Py each time. Then we also have to import pandas, which is a very common Python package that's focused on data manipulation and analysis. Again, let's hit run. This one only takes a second. And it is complete. I know it's complete because this little circle up here fills black when it starts to run, and then it goes back to empty when it's completed. Okay. The next thing we have to do is we have to actually read in data sets from this library and assign them to a data frame. A data frame is how you work with tables in Python. It's no different than an Excel table. If you open up Excel and you see a table, you see something that has data elements arranged by rows and columns. A data frame does the exact same thing in Python. It's just what Python calls it. So, how we handle a data frame from the NFL library is we are going to define the data frame name. And we want to import 4 different data sets from this NFL library. We want to import play-by-play data, roster information, team information, and formation information. So let's define 4 data frames. So data frame game log, data frame players, data frame teams, and data frame formation. Then we have to read a data set into this data frame, and to do so, we're just going to access the NFL library, and we do that by using this NFL alias name that we just gave it in the prior step. Then we run an import on the data set that we care about. In this case, it's the play-by-play data. So we have a specific import function, import PBP data. Then we have to pass in the time frame that we want to import. If you remember, we have about 24 years worth of data. We do not want to add in 24 years worth of data right now. Right now we're just learning. We only need a couple of years to work with. So let's create these square brackets, which essentially creates a list. So the Python function can actually look up at the values that live within this list. So we're going to put in 2022, separated by a comma, 2023. Okay. We're going to do the same for the players. And in this case, again, we're going to access the NFL library. We're going to import seasonal rosters. And we're going to do the same thing, 2022, comma, 2023, right? We have 2 years worth of play-by-play data. We want to make sure that our roster data corresponds. Same thing for teams. Access the NFL library. We're going to import team description. This time we can just create an empty parenthesis. We do not need to pass years into the team because a team is a team, right? The team doesn't change within a year. It's basically going to give you like team name, team characteristics, where does the team live, for example, what city, state, what conference, what division. All that stuff is static. It's not changing from year to year. So we don't need to specify a year for teams. Okay, and lastly, we're going to import the formation information. So NFL library, again, import FTN data. And again, this is formation information. This is going to correspond to the play-by-play data. So for every play, there's going to be a record in this formation information. So we want both years to pass through here, 2022 and 2023. Okay. Now let's print, just to make sure that we understand how this is going to look. We want to make sure that we've got data coming through successfully. So let's just print this last data frame so we can see how things look. So we'll just paste that. To print a data frame, all you have to do is just type the data frame out. However, the data frame is going to be large. So let's just pull the first 5 records. And to do that, we just have to do period head. Essentially what that's going to do is include your column headers and then the next 5 rows. Then we can run this and we could actually see what the data looks like in this df underscore formation data frame. Let's run that. It's going to take a couple minutes, so we'll pause and come back when it's complete. Okay, we are complete. I know this because my circle is empty and now I have a data frame to look at. So here, this is just a basic data frame. So you can see, just like I said, with Excel, you have rows and columns. So here's my columns. Here's my rows, stops at 5 rows because we did the dot head. We don't put the dot head in here and we're going to get a full data frame. It's take a little bit longer to render. Then I'll also skip some rows. I think it'll show the first 5 and the last 5. So it's an easy way to look at the data frame. And we got some information about, the season, the week number, the play ID. Then what's the starting hash? Is it left, right? Where's the QB's location? How many players are in the backfield? How many are in the box on defense? And so on. We also have a couple of other interesting fields in here. If the pass was dropped, if the quarterbacks had a quarterback sneak, a lot of information. Okay. So now that we have this, all we have to do is just take these 4 data frames and we need to push them to our SQL database. So the first thing we need to do to make that happen is we need to connect to our SQL database. And I'm going to copy the line of code because it's long, and I'll show you where you can access your connection. It's very simple. So if you remember, we created a reference further up here to the SQL Alchemy package, and we have this create engine function. So all the create engine function is going to do is it's going to establish your connection. And with a Postgres database that is hosted in the cloud, your connection is just a URL essentially. So where do we get this URL? Easy. We go back to Neon. Let's just start from scratch. So we'll come into Neon. So you can, if you have it favorited, that's great. If not, just Neon DB should pull up neon.tech. Come in, log in. enter your project. You should just have one project created, which we set up in the setup series. And now we are at the main landing page, okay? So what you can see here is we've got a whole bunch of pages along the navigation pane. We can live right here in the dashboard. And if you just scroll down a little bit, you can see your connection details. So you can see the database that you're connected to. You should just have one here. I named mine NeonDB to keep it generic. You might have something different. Hopefully it looks the same as mine. Then you have a connection string. Okay? A little bit of the connection string is blacked out here. This is my password. If you want to expose your password to copy and paste the full string, all you have to do is click the little eyeball. And now I can copy the string, come back to Jupyter, and all I'm going to do is just paste right over top of this, that whole thing. There we go. So now we have a connection established here. So this is the connection engine. This is where we're going to connect. It's got my credentials. We're good to go. So how do we get a data frame pushed to a SQL database? So we're coming from Python to SQL. So how are we going to do that? Luckily, Python has handy packages and handy functions for everything. So all we have to do is we have to basically utilize this function called toSQL, where we just say we want to take this data frame and push it to SQL. Then what do we want to call the table, and what are a couple of other parameters that we have to consider. Okay, so the first thing we're going to do is let's pick our first data frame, which is df. Actually, let's just do this. Let's just copy all of 4 of these. All right, paste them, and let's just delete everything after the data frame name. Okay, so we're just going to do df underscore game log dot to SQL, open parenthesis to kind of initiate the function. Then the first input parameter is going to be what is the table name that we want to call it in SQL. In this case, let's just go with NFL game log. Okay, that's the first parameter. Then we have to pass the connection into this function. So we're just going to pick engine, right? We took this connection string and we assigned it to this variable called engine. So we need to pass that into our function. Then we have to decide what to do if the table already exists in SQL. We can either overwrite the data, overwrite the entire table, or we can append to it. In this case, we're going to overwrite the data. So if exists equals single quote replace. Then the last input parameter is optional, but I highly recommend it. Otherwise, your process will probably fail if you have too much data. So what you want to do is you want to define a chunk size. And I pick 5,000. This chunk size just means it's going to process in 5,000 record chunks. If you try to push a 100,000 record table into SQL, there's a lot of opportunity for connection disruptions. So if you just do it in little 5,000 record chunks, it should succeed. I've never had a problem with this, so I would expect the same for you. Then let's just copy all this to the next 3 data frames. And let's just make sure that we give them new names, right? The next one is our players data frame. So let's just call it as such. Players, that's going to be the table as we see it in SQL. Next one's teams. And finally, formation. Okay. Let's add a notification that this process is complete at the end. To do that, all we have to say is print. You then a double quote, so we can pass a string into this print statement. And let's just say completed. So once these 4 processes run, we'll get a little note that just says completed. Okay, or we could say process completed. All right, you can define this. So I'm going to go ahead and hit run one more time. This again might take a couple of minutes. If it does, we will come back when this is complete. Okay, it looks like we're good to go. I know we're good to go because we have this print statement here that says process completed. This process completed statement is only going to fire after all 4 data frames have been loaded to our SQL database. It's because Python runs top to bottom. So this is the last step in this code block. We have a comment here that says process completed, so we know we're done. We also know we're done because the black circle up here went from full to empty. Okay, so these two things happen at the same time. The last thing we're going to do here in Jupyter Notebook before we head over to our SQL editor is we're going to clear out all the output from running our code in each of these cells, right? We've got a lot of junk here. So to do that, all we do is we go to kernel. So the kernel is essentially the engine that executes the Python code. And all we have to do is we have to restart and clear the output. So this is going to reset the kernel, and it's going to get rid of all this junk that's showing up. So you're just going to hit restart and clear all outputs. And there we go. Now we've got a clean program that we can rerun. So if we want to rerun this next time, so after we got a couple games coming up here this weekend, so we can rerun this entire script on Tuesday. All we have to do that is we come to cell. Well, let's click in the top cell that we want to run. We click in cell, then we just run all. So what it's going to do is it's going to execute each of these cells in order. Then you'll be good to go. So now we're going to head over to our SQL editor, and we could do this in 2 places. We could do this in Neon, or we can do it in dbeaver, which was the 4th video that we produced in the environment setup series. Okay, so we're going to start in Neon, and then we're going to head over to dbeaver because dbeaver is a lot cleaner interface and it's a lot easier to work with. And the first thing we're going to do is we're going to land on the dashboard page. And let's go check to see if our tables are actually existing. So first go to the tables page, and here you can see your branch, your database, which is NeonDB, and your public schema. And I have 4 tables, and I would expect that you have the same. Okay. Next thing we're going to do is we're going to go to our SQL editor, and we're just going to run a quick little query to make sure that we have data in one of these tables. So blank editor, all we're going to do is select. Every SQL query has to have a select statement and a from statement. The select portion of the query will show you what fields do you want to actually show in your output. If you want to show all fields, all you do is enter star. Then you have to specify what table you want to draw the fields from. And the syntax there is you have to include the database name, the NeonDB, the schema name, which is public, then the table name, which is NFL game log. We don't want to run for 20, 30, 40,000 records. Let's just look at the first 10 records. So we can do that by just a simple limit statement, limit 10. And now we should be good to view our results. Press the run button and scroll down. It's very hard to read, as I told you. Web editor is very difficult, right? Everything's blown up. It's very hard to follow this. Okay, you can see how many columns there are. There's about 100 columns or maybe even 200 columns. Okay, so let's move over to dbeaver so we have a little bit of a cleaner interface to work with. So dbeaver should have been installed in a prior step. So all you're going to do is just navigate to dbeaver. So for me, it's in recommended because I just installed it. Okay. You can ignore that first message there. So what you should have from a prior setup is you should have a connection already established. This connection is a NeonDB connection. You can see it's a Postgres instance. So all we're going to do is we're going to expand this little node. This is our database navigator where we can explore this database. Okay, so the first thing we want to do is locate databases, expand that. Then here's our database, NeonDB. Then within NeonDB, we're going to have access to the schemas, which in this case is just the public schema. So here's the public schema, and we can expand that. And one more time, tables is going to be the 4 tables that we just created. So we've got NFL formation, we've got NFL game log, NFL players, and NFL teams. So if we want to initiate a SQL query, the easiest way to start is to just pick a table, and then right click, generate SQL, and you can do a select, insert, update, all different types of SQL queries. Don't worry about any of those right now. We'll learn about those later. And let's just click select, and it'll give a recommendation. So this SQL query, and all we're going to do is just copy it, and we're going to launch a new SQL editor. So a new SQL script rather, okay? So right up here, SQL, new SQL script. Blank pane, paste what you just copied, and press run, which is found just to the left here in this little tiny middle bar, this little tiny orange arrow that's pointing to the right. If you run this, it should execute that SQL statement, and you will get a sample of the data that we have in this table. It's not every single column, it's maybe 30 or 40 columns. There's probably closer to 200 columns in this table. Okay, so you can go ahead and explore this table all you like. We'll do more of that in a future video, but ultimately it looks like we were successful accessing the NFL play-by-play library from Python and then pushing it to our SQL database. We will have another setup video where we'll focus on the Yahoo Finance dataset where we can track stock prices. I hope you enjoyed this video. Thank you. Thank you for watching. I hope you enjoyed the video. Remember, subscribe to our YouTube channel for free learning opportunities. Visit our website at datacoaching.io to set up a free personalized consultation. We'll be offering private, group, and corporate options, and follow us on LinkedIn for special announcements. Thank you.